All right, so good afternoon, everyone. First off, I'd like to say thanks to everyone at AMSIS. It's great to finally have a conference that's actually in my time zone, so I'm not jet lagged to hell. So for those that don't know, my name is Gilbert, and in my day job, I look after the Macs at a large multinational. And today, I'm going to be talking about one of the main tools we use to manage those Macs, and that's Puppet. So first off, who's heard of Puppet? Brilliant. Who knows what Puppet does? Who kind of knows what it does, but they're not really sure how it's different or better than what you use? All right, OK. So before we talk about how Puppet will change your life and it will be unicorns and all happiness, let's talk about how I used to manage my machines. Obviously, you need to configure your machine somehow. If it's simple preference, you can probably get away with a profile. If it's a bit more complex, you're going to have to use a script. But however you manage it, your machines get magically configured somehow. But then what happens? What happens when an OS update hits and it wipes out your script's work? You have no idea. The minute you've applied your configuration, things could start changing. You just don't know. So this is a 1,000-foot overview of how Puppet works. You start off by defining your desired state. Every time Puppet runs, it will compare your desired state with the actual state of the machine. And then it's going to calculate the drift between the two. And if it needs to, it's going to make a correction to bring the machine back to your desired state. And at the end of the run, it'll send a report saying if it's done something, if it hasn't done something, if things went well, or if things went wrong. So let's say one day you get this email from your coworker. Your plans for the evening are evaporating before your eyes. You've got different Macs with various combinations of printers. Some have one, some have 5, and you've got everything in between. It's a disaster. You've got different printers on different Macs, and somehow you need to get them all back before you get shouted at. So you start to work. If you've only got a few Macs, you could conceivably walk around and do it by hand if you really felt like it. If you've got more than a few, and you've already got your configuration of those printers set up in a package or a script, and you have a way of reliably redeploying that configuration, use it. That's fine. But what if you don't? What if you've got a really complex setup? You've got different departments with different printers, different subnets with different printers, different builds, and you've got the unique snowflakes that have this weird printer in the corner as well. You've got to write a script to fix this. It's terrible. So, but quite frankly, that pint of beer is disappearing into the sunset, so you just give up and you go have a beer anyway. Obviously, terrible. So how would I handle this with Puppet? I'm not going to do anything. I'm just going to sit there and let Puppet run again. Because when it runs, it's going to compare the current state of the computer with the desired state, and it's just going to fix the machine, bring it back to our desired state. So the worst thing that's going to happen is our help desk gets a phone call, and if they're feeling nice, they'll say, open Munki, hit run Puppet. If they're feeling not so nice, they'll tell them to go away, come back in half an hour if things aren't working again. So if you don't take anything else from this talk, take this. Puppet gets you to the pub quicker. Right, I'm going. Yeah, right, let's go. So let's say you want to copy a JPEG for a wallpaper. You're obviously going to need to set ownership and permissions on that file. And yes, I know I should be using a package for this, but we're doing everything the hard way today. So even this relatively simple example is relatively convoluted. You need to know what cphmod and chown do for a start, and we're not even testing to see if we actually need to do these things. We're just doing them anyway, and that's pretty dirty, really. So this is how we do it with Puppet. If you've never seen Puppet code before, it's relatively easy to read. We're making sure the file's present. We're giving Puppet our source file and setting the owner group and permissions. So as we've just seen, we're not really describing what needs to happen to the machine. We've just described our desired end state, what the file's content should be, what the permissions and ownership should be. We're not concerning ourselves with how any of those things are actually performed. So Puppet is idempotent. And you have no idea how glad I said that right. Once the initial change has been made, assuming nothing else changes on the system, no further changes are going to be made. This is built into the heart of Puppet's philosophy. Unlike scripting it by hand, where you need to test the current state of everything before you perform an operation, Puppet's just going to do all that for you. And Factor is a tool that is installed alongside with the Puppet tool. So it works in conjunction with it. It gives you little bits of information about the machine it runs on. They're called facts. Factor runs at the start of every single Puppet run, and it returns information to the server. So it gives you information like what operating system we're running it on, what network's the machine on, are we running on a VM, how much RAM does the machine have. So why do we care? How is this useful to us? As I mentioned, I work for a very large organization, and we operate in many countries, and those countries have many sites within them. And for some reason, they all love motivational wallpapers. We've got targets, we've got staff information, we've got all kinds of junk on there, and they're updated reasonably regularly. So Factor lets us truly treat our configuration as code. We can use if statements, we can use variables. It's just like it's a simple programming language. In this example, we're deploying one wallpaper for a particular subnet and another one for the rest of them. But this is a bit of a pain to edit every single time. There's a relatively high barrier of entry. Every single person who's going to be modifying what wallpaper the machine gets needs to know how to write Puppet code, which isn't necessarily going to be the case. So to combat that, there's another tool called Hira. Hira is a way of passing data into your Puppet code. It's written in YAML, so it's a bit easier to get into than Puppet code. As the name implies, Hira uses a hierarchy of data. It starts at the top of your defined hierarchy, then moves down until it finds a value it can match. So this is our fictional Hira configuration file. So the bits in the curly braces with the percentage marks are facts from Factor. So our directories and file names on our Puppet server can match what the machine is returning about itself. So the server is going to start at the top of this list and keep going down until it finds a matching configuration file for that machine that also contains the value we're looking for. So if a machine has its site fact set to London, it's going to have our motivational wallpaper deployed. That fact could be the output of anything. It could be based on the nearest domain controller, the machine's subnet, anything you can test with a script, and obviously there's loads of built-in facts as well. So we are a few minutes in now, and I'm sure there are some of you sitting there wondering why on earth I would want to do any of this. There are loads of products that provide you a nice GUI for managing a machine. They're easy to pick up, you get a phone number to call if you get stuck, and you can shout at them if it all goes wrong. So I've used tools where I know a change has been made, so I call product X's support line, and they tell me to dig through this blooming database log file. It's like, are you kidding me? I have no idea who's made this change. They've stuffed up all my machines, and not like someone's going to go, yeah, it was me. I broke every single machine we have. So we use GitLab to host our Puppet modules. It's like GitHub, but we can host it internally. And every change that anyone makes goes through what's called a merge request. That's just like a pull request if you use GitHub before. And so it means that every change is reviewed by another person before it goes into production. So hopefully no one will nuke all of our machines. And with our config stored in the Git repo, we're able to see who exactly changed what. And because there's a commit message along with each commit, we can see almost as importantly why they made the change. So I'm sure you're all pretty bored now, so let's go into the demo, and hope the demo gods are not going to kill me. Right, hide you, and go over. And that's not what I wanted to do. Let's switch the display. How do I mirror these days? Has that gone horribly bad? It's not so bad. That'll do. Okay, so this is a normal 10.11 client. I've done nothing to it other than install the Puppet tools and configure them. So the first thing we're going to do is run Puppet. That's a shock, isn't it? And we're going to tell it to wait for a certificate because Puppet uses certificates to authenticate the client to the server. Well, it can do. We are in this case. And we'll get to that in a second because I can't type and talk at the same time. So as I mentioned before, Factor runs at the beginning of every single Puppet run. And before factor runs, something called plug and sync happens. So that's when Puppet throws down all of the facts and various other bits that Puppet needs to run onto the client. So this happens before every single run, so it happens automatically. You don't need to do anything, just stick all your facts in the right directory. And you see it's pretty quick. And if we run Puppet again, it's not going to put all these down again. It will check what's on the disk before it actually sends them down. So that's completely boring because we've applied no configuration to our machine. So let's actually apply some configuration. Read that? Big enough? Can you read that? Is that fine? Yes? No? All right. That's fine. You don't need to see the bits that are highlighted at the minute. All right, so first thing we're going to do is set up a file. It's one of the most basic things you can do with Puppet is controlling the presence and content of a file. So let's go and have a look at it. So we're saying, yes, I would like to make a file, please. And we're telling it the path we want it to create, user shared Puppet created. Make sure it's present. We could also say absent if we want to make sure this file is never on our systems. Setting the ownership group and permissions, just normal POSIX. You could put root and wheel in here if you wanted to. No. Be quiet, Alistair. All right, so we're setting our content as well. It's just a basic string. We could be using a file source, or we could use a template if we want to do a bit of dynamic content. We'll come to those a bit later. But there we go. We've got our content for our file. So let's run over to our machine. Half an hour passes. Puppet runs again. Compares the desired state of our actual state, realizes we're absolutely not in compliance, and it creates our file. So there's our file, and if we open it up, we can see that the file says we want it. So let's say for some reason an OS update hits, nails our file, it goes into the bin. The user doesn't like us for some reason. They don't want us to control their machines. Puppet runs again. So rather than just most management tools which will, say, record that they have performed this action on the machine in an internal database, Puppet is continually comparing the state of the machine. So you don't actually need to use smart policies or whatever to say, check for this. It just does it. It's built in. The machine knows that the file's not there, so it puts it in there. So let's say they really hate us for some reason, and I hate IT, go away. So they hate us, we're controlling their machines, sucks to be them. Puppet runs again, and so it's not just checking that the file exists, basic things like that. It's going to go in and actually inspect the contents of the file, and it's also reporting to us exactly what it's done, saying it's taken out this file, and it's put this line, and it's put this one back in. And it's also created a copy of it. We could optionally ship the original file up to the file server, so we could perform analysis on it if we wanted to, if it was that important to us. This isn't, so we haven't. So let's go back, and so that's a file. It's basic and quite dull, really, but so let's go to something a bit more interesting. Should have mentioned before, this is obviously Hira, and whilst we can pass in variables, we can also assign classes to our machines. And a class is a collection of Puppet code. It should really just do one thing. So this class is setting up our admin user. So Puppet knows about users. It can create users. We don't have to do any special work to get them working. Defining our username, saying it's there, nice name, make primary group, additional groups is in, so it's going to be an admin, home folder. Iterations, password, and salt is, obviously I didn't type this out by hand, because who knows what that means, but we'll show how you generate that in a second. So something to note here is we're also going to hide our admin user from the GUI. And I've put in here require user local admin. That's because Puppet doesn't necessarily run things top to bottom. It runs it in whatever it damn well feels like, unlike a bash script where it will run from top to bottom. So I like that. Some people don't like that. The reason I like it is because you could have two completely unrelated pieces of config. Let's say we're creating this user and we've got the file we previously created. They don't relate to each other in any way. So if the file failed to be created, the user's still going to be created. However, this bit here which hides our admin user from the GUI does depend on that user to exist. So that's why we're explicitly saying we require that to happen. We could also say, I need this to happen before the user's created. In this case, it'd be useless, but if it was something else. And there's various other ways of notation, use like arrow symbols and things like that. So we are going to create our admin user. Puppet runs again, half an hour rolls by. It's going to see that our user does not exist, and it's going to go and create it for us. Come on. You know you want to. There we go. So it's created our admin user. It's hidden it for us as well. The user does exist. And it's in the admin group, which is what we wanted. But let's say for some reason a well-meaning tech, for whatever reason best known to themselves, changes the local admin password to something we don't know what it is. Oh well. So change that. So the password is changed. Puppet runs again. Half an hour passes. And it's not going to create the whole admin user again for us. It's just going to change the bits we need it to change. So it's going to change the password salt and iteration, so the password hash for us. So let's put those specific bits back to what we need. So how do we generate this? Well, Puppet has a thing called Puppet Resource, and it's probably easier if I just show you what it does rather than trying to explain it. Local admin. So it will go and inspect what is on disk currently, and it's going to model that into Puppet code for us. I could literally just copy and paste this into my manifest now, if I so wish to. So that's creating a user, and you see we've hidden it, so it's not going to show up in sysprefs. Not showing up here, and it doesn't show up anywhere else in the GUI either. So that's creating a user. As I mentioned before the run, all the facts about the machine, the bits of information, are shipped up back to the server. And we can use those to dynamically apply configuration to our machine. So over here, we have, that's really small, something called Puppet Board. This is a web interface to PuppetDB, which is where all the information is shipped up. And we see we've got our machine in here. And we've got the results of its previous few runs, so we can see that first few were unchanged, and then it started changing its configuration. And we've also got all of the facts about the machine. And one of those is time zone in the format system setup likes it. So we can see at the moment it's set to American, but this is obviously incorrect, so we need to set it to the one and only correct time zone. So let's have a look at how that will happen. So we are literally just specifying the fact as a variable. And we're saying, if this variable does not equal Europe London, run this command. Normally, if we didn't have this if statement around it, this command's going to run every single time Puppet runs because we're not giving it any context as to when it should run. There are various other ways of saying you should only run this only if this evaluates to true or if this doesn't evaluate to true, but I like doing it like this. So can we see just about see that this currently thinks it's 8:23 a.m. Puppet's going to run again. It's going to send the facts up to the server. The server's going to say, hey, your time zone is completely wrong. You need to run this to make it correct. And our time zone has not fixed itself. What is going on here? Glad the GUI is lying to me now. There we go, it ran again. First time that's ever failed. Of course, demo gods had to kill me. All right, so that's how we can use Factor to dynamically configure our machines. Another thing is, as I said, is incredibly common in my environment is setting a wallpaper. There are two parts to setting a wallpaper. In this case, we're deploying the image, and we're also going to deploy a profile, which will set the wallpaper for us. So we're going to see it creating the intermediate directories to deploy the wallpaper file, and then it's going to install a profile for us. And we can see that our wallpaper has now been, our wallpaper's now been changed. They can't manage their own wallpaper because we hate our users, all of us. And we can see that there's a profile in here. And because this is Puppet, we could take this profile out. Yes, I want to remove it. Somehow I've got the admin password, a well-meaning tech has decided that this person doesn't need the profile on. Puppet runs again next half an hour, and it's going to put that profile straight back for us. There we go, and the profile's back in. You can see that the profiles icon is back there. So as I mentioned before, we can use Hira to pass variables into our Puppet code. So we see here that in this current file we're working in, our motivate variable is set to false, so don't deploy our motivational wallpaper. But as I mentioned before, Puppet uses a hierarchy, or Hira uses a hierarchy. And here we have top of our hierarchy is sites, and we're looking for the site fact. This machine happens to have its site fact set to London. And if we zoom in here, we can see that in our Hira data, so it's the root of our Hira on our server, we happen to have this sites directory, and just by luck, we happen to have one that says london.yaml. And we've also got OS family here. That obviously is the operating system family. In Puppet land, that's Darwin. If we were running on Ubuntu, that's a DB. But OK, so let's have a look in the London file. And zoom out so you can actually read the damn thing. So we are going to set our motivate variable to true. So what has that done? In our wallpaper class, we can see that there is this says it accepts a variable called motivate, and the default is false, but we're saying it's true in this case. We're setting up some directories for our wallpaper to go into, ensure directory, and here's the real meat of it when we get to testing whether this variable, which we've passed in with Hira, so the text can just modify the YAML file, they don't need to know about Puppet code, just send this in. And this is going to set this path variable to the path of our motivational wallpaper. And we're using that variable to make sure the file is present. Otherwise, if it's not, well, if it's set to false, because that's the only other option, because it's true false, but hey, we're using our standard corporate wallpaper. And we are setting obviously we're setting a profile, and we're using that a template for that. So we're passing this path variable into the template. And we're finally requiring that this file exists before we do anything, because obviously we want the wallpaper JPEG to be there before we try and set the profile. So let's have a look at this profile. If you've seen a wallpaper profile, which if you're in the Munki talk you have, because this is exactly the same one, it should look quite familiar, nothing too special about it, apart from this placeholder here. So Puppet is aware of all the variables you set, so I just don't need to pass any variables into the template. It just knows that this path is there, and it will replace whatever I'll set the path variable to be with this. So let's run again, because we are now getting our motivational wallpaper. Shift you over there a little bit. Half hour passes, Puppet runs again, sends its facts up to the server. The server now knows that this is a London machine, so it needs to be told something, and MCX takes a good long time to actually change this. Come on, there we go. So, because I don't know about you, but I've uptime's about 6 months. So that's how we can use Hira to pass configuration into our Puppet code without actually knowing about Puppet code. So let's head back to our Darwin.yaml. And we're going to do something else that's quite common for Mac admins, and that's installing a package. This is a well-made package because it's made by a fellow Mac admin. Puppet struggles with other packages that are made by other vendors that sound a bit like Adobe and other similarly badly made packages. It isn't necessarily the best tool at installing packages. There are much better ones, but it can do it. So we're going to install our package. But because Puppet, like many other tools, isn't actually aware of what it has installed, when the package has finally installed, come on, computer, I'll go slow. Okay, so this installed stuff into /user local outset. Yeah, I meant to do ls on that. And let's say for some reason this file gets wiped out. Who knows why, but there we go. It's gone, but Puppet runs again the next half hour. It doesn't know about this. Puppet's not aware of what it actually is installed. It just knows I've installed a package. Well done. So a better tool to install your software is Munki. In fact, it is the best tool, but there we go. So we are going to install Munki. So what this will do is install the Munki tools. It's going to deploy a profile to configure things for us. So we're going to pass in our configuration. So we're going to set our repository URL, our client identifier, and tell it we want to actually install the Munki tools. And it's also going to load all the launch daemons for us, so Munki's ready to go straight away. And we're also going to deploy Sal for some reporting. So Munki's going to, Puppet's going to run. It's going to go away. It's going to install the package for us, get our profile deployed, and then load all the launch daemons. And while that is doing stuff, let's go and have a look at how it actually does its installation. So we've got loads of options you can pass into this particular class for configuring the various options for Munki. We'll come to how it installs the tools in a second. Once again, we're passing in a profile. We're using a template, obviously. And notice this time we haven't had to specify any variables for the input on the template because these are all available to the template to use as well. So they just get passed straight in through Hira. So if the Munki tools are already installed, this class will manage the service or the launch daemons. But because Puppet doesn't check the state of the machine during a run, and because Puppet sucks at installing packages, it doesn't know that it's installing launch daemons. So we're only telling it to keep these services running if Munki is already installed, because otherwise it's going to fail and say, hey, I can't find these services. So when we install Munki, we're making sure our package is installed, and then we're firing off this exec to manually load the launch daemons. And another way of controlling when this exec runs is by saying refresh only. So this will only run when explicitly called. And we're saying we want to call this by subscribing to this package. So whenever this package changes, the Munki tools package changes, fire off all these to load all the launch daemons. And this only happens the first time because obviously the package only changes once when it actually gets installed. So that's done. Let's open up Munki and get our software reinstalled because kick this off. So there we go. Munki is actually good at installing software, unlike Puppet. So as I mentioned, we are reporting into Sal. And we are using Sal as our source of truth because Puppet as I mentioned, uses certificates to authenticate the client to the server. And obviously you have to sign those certificates. By default, you're signing those certificates by hand. Pretty tedious. Not sure anyone really wants to do that. So the next step is enabling auto-signing. So what some organizations do is set auto-signing to true, which means I trust absolutely any machine that can communicate with my Puppet server, which I don't. And unless you've got the most secure infrastructure ever and your Puppet server cannot touch the outside world, that might be all right. You might be able to say, yeah, sure, let's auto-sign, but mine does touch the internet. So another thing you can do is pass it a script. And based on that return value of that script, if it exits 0, it's going to sign the cert. If it doesn't, it won't. And that script can do whatever the hell you want. And mine talks to Sal. So Sal has an API. And at imaging time, we use that API to create the machine record. And let's head over to Sal. You can see we've got one machine in here. And there's literally just one machine. So at the beginning, when this machine ran Puppet the first time, it talked to the Puppet server, sent its serial number. The Puppet server then talked to Sal and said, hey, do you know about this machine? Sal went, yep, sure do. So it signed the certificate. However, if we had another machine, which I happen to have here, which obviously isn't in Sal, we run exactly the same command. Wait, always get it wrong. So 15, exactly the same command we ran the first time. It's going to send its serial number and along with its certificate signing request to the server, but the server is going to tell it to go away after 15 seconds. Come on. There we go. So it's not going to get a certificate. So that, in a nutshell, is what Puppet is OK at. So let's carry on. So that obviously sounds really freaking awesome, doesn't it? Puppet will change your life. You should go and use it right now. Yeah? But yeah, obviously there are things that Puppet is not quite so good at. It is not very good at installing packages, as we've just seen. But quite frankly, it is no worse than pretty much any other commercial tool that I've seen anyway. So save yourself the trouble and choose Munki. There we go. Puppet OS X is not Puppet Labs' primary focus. They don't really make much money off it. In fact, I think I know one person who pays for Puppet Enterprise on OS X. Thank you very much, Alistair, for getting our bugs in. So if things break, you're not going to be top of their list to get things fixed. It's generally been pretty solid for me. There have been odd 1 or 2 bugs when an OS update hits. Things have stopped working. But, so you've just got to test it a bit more rigorously than you would normally, but really you should be testing these things because this is your core management product. So what is Puppet good at then, in my opinion? It's good at keeping your machines compliant. You know exactly what state your machines are in at any time. You know if things are changing. Whenever the configuration changes, it reports it into PuppetDB. For example, I have machines which I cannot allow to have USB drives plugged into. So I have a profile which restricts that. So I know that all times that profile is going to be installed. And if it ever somehow gets removed with someone on site removes it by accident or whatever, I'm going to get told about that. So with Factor and Hira, you can inject at various levels of hierarchy different options in your configuration. Most of my machines are identical. They're basically all the same, but they have little bits that are slightly different that make them unique. So I can inject things at various levels of the hierarchy all the way down to the individual machine. And Puppet can be as heavy or as light touch as you want it to be. You may just want to make sure your machine's encrypted. That's it. Fine, you can do that. You may want to have 50 profiles installed, managed down to everything, every single thing, 100 scripts running. You can do that if you really want to. But the main thing I'm trying to get at is that Puppet won't do anything secret in the background. It'll only do exactly what you tell it and nothing else. It's not going to try and be clever for you. So, has anyone got any questions at this point? Okay. Have we got a microphone anywhere? Yeah? All right. Oh, good. All right. Have I got to turn it on, though? Oh, Jesus. No one else had to do this themselves. Hint. How do you turn it on? Oh, there you go. Is that working? I don't know. Let's go for a quick one anyway. Oh.
This is on? Oh. How fast is I know that Puppet as a company is normally focused on large Linux infrastructures and everything else. Mm-hmm. How fast do they update for new versions of OS X?
Open source, it's generally the same as every other platform, isn't it? I've not noticed any slowness. For Puppet Enterprise is a bit slower. I don't know why that is, but yeah,
okay. But like if you're using the open source client, you haven't noticed any problems?
I've not noticed any. Whilst I don't really track what versions are on Linux, because I have many more OS X Puppet clients than I do Linux ones, it seems to be pretty much on a par.
Okay. So like for El Capitan release day, you were not worried about it at all, or?
No, it worked fine. Yeah.
Okay.
There's a question just up there somewhere, or one even further back.
All right, I'm going to try to.
So it's heading that way.
Hello. Well, just following on from that question, is Puppet the kind of default installation resistant to users upgrading the OS themselves, or will that require Puppet to be reinstalled? If your users are admins and they go to the store and they say, "Hey, I'll have the new OS," will it wipe out the infrastructure that Puppet needs?
Not now, because it installs to /opt, which it shouldn't remove. It might. Who knows what Apple does? They wipe out the receipts database because they feel like it.
I presume
Who
you get
knows?
something in your Puppet
shouldn't.
database saying, "Oh, this client has vanished," or I guess
yeah,
you'll get
it should be fine. Everything is in /opt, so Apple should leave that alone. Should.
I think there was a comment. There was a comment on an earlier presentation about getting ahead of it and getting a developer account and getting pre-release versions of the Mac OS. I'm a big advocate of making sure you know what's going to happen before the users do. So, so you can try it and then say this is going to be a problem, and then you can find a solution to it before general release.
Yeah, a developer account's £79 a year. So if your organisation doesn't care about the Macs enough to pay £79 a year, they probably don't care at all. So let them get on with it.
Who's next for a question?
Anyone?
Oh, if you can throw it really hard down this way.
No one's had their head hit yet.
Everyone keep your eyes open.
Now's the time.
It's coming.
Nice. You broke it.
So this is open source that we've been talking about. To go back to Rich's question, and it was about when is it ready for El Capitan, for example. At the time of El Capitan release, they only had one file that was inconsequential, and therefore an OS upgrade would not have broken it. The other thing is that they still did, however, lag 2 months behind and have now lagged by 2 weeks on the most recent release, which has a lot of speed improvements for the fact that at the core it's Ruby. They're doing a lot of improvements in general of replacing something called mcollective in the core Puppet Enterprise product. But you wouldn't let customers upgrade generally unless you knew that your management tools were going to continue working on the other side. It was only one thing where you couldn't do a clean install on El Capitan betas just because they had one bill of materials file. And then the other side of the package installation thing is that since they didn't use the receipts database, because they have their own little dot Puppet folder of receipts, you would still be able to quote unquote enforce installs because it doesn't care about the systems package database. Not that it actually responds particularly well beyond the fact that it's installed it once ever.
Thanks. Anybody else got a question?
Oh, yeah.
Yeah, just a quick question. I've had a go with Puppet in the past and never really got very far with it. And I see a lot of stuff online where people are talking about you running Puppet with Foreman, Ansible, Chef, and SaltStack. Are any of those worth looking at?
Well,
or should we just forget those and just stick with Puppet and Munki?
So SaltStack, Chef, and Ansible are similar but different to Puppet. They do the same thing. They're different configuration management tools. There's going to be talk on Chef from Nate at Facebook tomorrow, I think. Yeah. Yep. That's another one written in Ruby. Foreman is a web UI for Puppet. Yep, you can certainly look at those. That would kind of take place of Hira. So that's applying configuration to nodes. And it also has reporting in as well. So that would also replace the PuppetDB end. So we've seen what we saw in the web UI, that is Puppet. That's a hooking into PuppetDB, so that's live from PuppetDB.
Okay. Anybody else? There's one just over there. Again, minding the camera.
Always by the camera.
Hi, Graham. So have you been on Puppet 3.8 and moved to 4 yet, or are you just on...
We are currently testing Puppet 4.
So have you looked at what the main troubles are moving from 3.8.4 to 4?
Quotes around your permissions, in fact. It's a lot more picky about quotes.
Right. And paths, I've read, is that an issue as well in terms of...
No, that's been fine. That's the main problem I've had with moving my Puppet code.
Okay, cool. Thank you.
There's one more down here.
I'll do an increment.
Bit of a long shot.
At Puppet, there's a whole how-to or what you need to do to upgrade from 3.8 to 4. There's some native fact changes and things like that you you can write ahead of time on your manifest. You can set some settings, and that'll tell you, hey, this is broken, this won't working for. These are the things to change. It's not too much. There was some editing I had to do because we've had Puppet for, I don't know, 7 years at this point. So our configurations had a bunch of really bad things that we had to change. But generally, it was pretty simple.
Yeah, the main difficulty in my organization was that the configuration files moved from /etc puppet, puppet.conf, to /etc puppet labs puppet. So the location's completely moved. So you've got to take into account that, especially if you're writing it out with another tool, imaging time or what have you.
Oh, I can see a hand up there. So just to
Lord.
the left of the camera, in front of Mike.
We're going to have to go and...
Yep. Thanks. Just looking at Puppet 4 at the moment, there's a bug that I'm tracking. If you use their pre-compiled installers for OS 10, 9, 10, or 11, even though your machine may be running El Capitan, it may not be able to run the Puppet 4 dedicated install. You'll fail with illegal instruction 4. However, if you use the gem installers, they work fine.
Yeah, that's a bug with certain CPUs, I think, isn't it?
Yeah, so things like Core 2 Duos, 2010 Mac Pros, and stuff like that.
Anybody else? I think looks like it's about it. So
Okay, so
so
I've got a bit of pimpage to do. If you are from London, we have a group. Ben mentioned it before. We meet roughly 4 times a year. We have talks, a bit like this one. We talk about nerdy stuff, and we normally end up down the pub. So it's like a small version of here. If you want more information, hit the website, speak to me, speak to Ben. He's the big tall cripple guy. So that's it. I'm on Twitter at Graham Gilbert. All the slides and code is going to be up on my website shortly at grahamgilbert.com. So really, there's just one more thing, and see you in the pub.
Thanks.